Okay. And so, yes, this lesson is on the functional groups called alkenes and alkynes. And you guys have started to write that, which is excellent. And so now we're going to be looking at hydrocarbons, compounds made up of hydrogen and carbon, that have a special arrangement of atoms. They have a very specific way in which they're arranged. The alkanes that we saw a couple days ago are very simple. They're all single bonds, and they're filled full of hydrogens. And that's what it means to be saturated. Today we're going to look at hydrocarbons that have double and triple bonds between the carbon atoms. Because remember, carbon can bond in many different ways. Carbon can have 4 single bonds, or it can have a double bond and 2 single bonds, or it can have 2 double bonds. There's many ways in which carbon can bond. Now, when we have these specific arrangements of atoms, we have what are called functional groups. Let's take a look at some examples of some functional groups. So you can have carbon multiple bonds. Here we've attempted to draw the carbon bonds using various characters on the keyboard. So here we just used an equal sign. But if we were drawing that out, you would draw it out perhaps like, oh, I don't want that color. I want dark. You'd draw it out maybe like this, carbon, double bond, carbon, and you can see there's 2 more bonds available for things to do. I just put it up instead of down. Here we've used an equal sign with a little underline. That's supposed to be 3 lines, again, representing a triple bond, and then 2 other bonds coming off the end. That's what we're going to look at today. You can have all kinds of different bonding structures between some slightly different atoms. We're going to look at that right at the very end. That's going to be our lesson on Monday. We'll look at some other functional groups. And you can even have multiple bonds to other atoms like oxygen. This particular functional group is called a carbonyl group. But we're not going to go into that naming. So today we want to just talk about the double and the triple bonds. And I'm going to go a little out of order on the slides here in a moment. So if you're writing down the next slide on alkenes, that's good. But don't go past it. I'm going to do something else here. I'm going to try to condense the lesson in so that I can get everything in before I have to go. So if you're working ahead, it's okay to go to the next slide, but don't go beyond that one. So the functional group we want to deal with today, and actually there's 2 of them. The first one is called alkenes. And you'll notice they end in -ene instead of -ane. And an alkene is defined or characterized by the fact that it has 1 carbon-to-carbon double bond. Now, alkenes are called unsaturated hydrocarbons because they contain fewer than the maximum number of hydrogen atoms bonded to each carbon atom. Vegetable oils contain unsaturated fats, so they're unsaturated, and they all end in -ene. Let me give you a little explanation on what we mean again by saturated and unsaturated, because I I kind of dismissed that last time we ran through it when we were talking about the alkanes. If I have C, C, and the single bond is there, then I'm going to have to put 3 H's on each of the carbons. All right? And we've already seen the name of this one. What is the prefix for 2? Do you remember what that is? What was that prefix for 2 carbons? F. And because they're all single bonds, what do we end it with? F? Ethane. Ethane. So this is ethane. Ethane. It's right full of hydrogens. If I have a double bond, how many hydrogens can I put on the first carbon? I can only put 2. And on the second carbon, 2. Now notice, and that bond's not in a good place, but you get the idea. Notice for this particular compound, if I could break that double bond, I could put 2 more hydrogens on it. So it's not full of hydrogens. It's not saturated with hydrogens. That's what we mean by saturated. That is right full of hydrogens. So this particular compound right here, we say is saturated. It is a saturated hydrocarbon. It is saturated with H's. That's what it's full of. This one here is unsaturated. It has room for 2 more hydrogens. Okay? So alkenes, because it has a double bond, they are unsaturated hydrocarbons. You could do a chemical reaction to add more H's. All right? So that's what we mean by saturated versus unsaturated. Now at this point in the lesson, I would start going over some names and structures, but I want to jump ahead and define the alkynes, the next group, and we'll work on them all kind of together because they're really named very similarly. So alkenes have a double bond, and they're unsaturated because you can put more H's on them. So what I want to do now is I'm going to jump ahead in my note, and I am going to go to the alkynes definition. Didn't want to do that. Let me back up. Sorry. I wanted to move this thing. So an alkyne contains a triple bond. Again, an alkyne is also unsaturated because with the extra bond on the carbon, you lose another 2 hydrogens. So it has also room for more hydrogens to be added to it. So again, for the unsaturated, I'll just add a little picture under here. The simplest one here, we've got a couple of those, and this thing only has 2 H's on it. I should have maybe had you name that one with the double bond on the other page, but we can try to name this one. The naming system, again, is quite easy. How many carbons does it have? And what kind of bond is it? Notice the last bullet. All end in -ine. So when you see a triple bond, the end of the name is -ine. When you see a double bond, the end of the name is -ene. When it's all single bonds, the end of the name is -ane. So this particular thing with 2 carbons and a triple bond, what would its name be? What starting word represents 2 carbons, and what do I put on the end because it has a triple bond. What would it be called? Yep. Ethine. Ethine. That's correct. This is ethine. What would have that other chemical that I just drew on the other page that had the double bond in it and said, what would it have been called? It had 2 carbons as well. What name could have we put with that thing that was on the other page that was unsaturated? It had a double bond and 2 carbons. What do you think we could call that? And yes, I'm going to pick on Bethany. What do you got? It had 2 carbons. Ethene. Ethene. All right? You're going to need that table for all of your numbers of carbons so that you know what they are. I'm not going to draw it on the board right now, but we're going to need to know that. Okay, so let's go ahead and name some of these things. All right, so now I'm going to go, and I will go ahead with just a chart that looks like that. And no need to draw the lines because we're just drawing things. The headings are the important thing. But if you have a ruler available, I guess you could. Now, I'm going to break this into 2, right? I'm going to do, we're going to have 1 carbon here. Actually, hold on 1 second. I gotta be careful here. I've set myself up for a problem because I'm rushing a little bit. So, can we have a 1 carbon that has a double or a triple bond? Why not? Yeah, excellent. Hydrogens can only have single bonds, so there is no yne or ene that has 1 carbon. So let's change that to a 2. And I'm going to break the line in half, right here, my group in half, because I want to look at both the double bond situation and the single bond situation. So, structural formula, condensed structural formula. The structural formula looks like this. And again, we've got an H and an H, and I'm running out of room here because I put that line, but we've got the H's on there. And if we condense everything together, CH2 double bond CH2. And its chemical formula, C2H4. And its name, a double bond with 2 carbons, ethene. All right? Notice in the chemical formula, the number of hydrogens is twice the number of carbons. And remember yesterday or the last day, it was twice plus 2. Well, we've taken 2 hydrogens away to make the double bond. So an alkene always has twice the number of hydrogens as carbons. C. What happened to the number of hydrogens when I added another bond? By how much? By 2. So every time you add a bond, you have to remove 2 H's so that the bond can be formed. Condensed CH, CH. C2, H2. For an alkyne, we double the number of hydrogens, but then we subtract 2 because we've made a bond. The name of this? Ethine. Ethine. 3. I'm going to go straight to the condensed structural formula again because it's nice to see all that, but it's handy to write it down. I'm going to have 3 carbons. I'm going to have a double bond which means how many hydrogens can go on my first carbon? Yep, 2, because it's got to add up to 4 bonds. How many hydrogens go on the next carbon? Yep, 1. And how many on my last one? 3. Are we okay with that idea? It's got to add up to 4, the number of hydrogens and the number of bonds. So that's 3. C3, how many H's? 6. Because remember, if it's got a double bond, there's twice as many. Does anybody remember the prefix for 3? It's prop. It's prop. And that's a double bond. It's not YNE for double. It's ene. Propene. It's ene for double. It's ine for triple. This is propene. C, C, C. This time I'm going to put a triple bond. How many H's on the first one? 1. Second one? None. No H's on the second one. H's on the third one? 3. C3H4. 4. They're not always the same. Nope. Nope. Because now I'm adding CH3s, so it's not close to being the same. Name of this one? Propine. 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 Yep. The assignment is on there for today. It's on there. You're using a device that's probably not talking to it nicely. I don't have the next day's work on it, but the assignment is on there. Okay? Let's do another one. 4. Now I'm going to do 2 blocks of 4. And the reason for that is there's now going to be 2 different types. So let's look at 4. 1, 2, 3, 4. All right? And I'm going to start with the double bond. And I'm going to put the double bond right there. Okay? Now, there's also a second version of this. 1, 2, 3, 4. I can also put the double bond there. Now, those are 2 different molecules. The position of the double or triple bond will result in different molecules. Okay? H2, H, H2, H3. Okay? This one, H3, H, H, H3. All right? Chemical formula, C4, and how many H's? H8. And notice that's true for both. They're isomers. They have the same formula, but different structures. That means I have to have different names for them. The name for the top one is called 1-butene. Nope. Listen up, folks. Again, I got to go in 10 minutes, and I want to get to the point where you can do the assignment and the homework. This is called 1-butene because the double bond comes after the first carbon. What will the second one be called? Still has a double bond in it. Notice I've just moved the double bond. I put the 1 there because the double bond comes after the first carbon when I count the carbons in a chain. Yep. 2. 2 butene. It's still a butene, but the double bond is in a different position. Okay? All right? So for alkenes and alkynes that have 4 or more carbons, I need to put a number to determine where it is. I'm going to go back up to another empty slot right there. And I'm going to do, again, 4. And this time I'm going to do it with a triple bond. And I'm not going to draw them both. Let's just do one of them. Let's go 1, 2, 3, 4. And I'm going to put the triple bond in there. We're moving down still. We're moving down. I just needed a clear screen. How many H's on the first? 3, 0, 0, 3, C, 4, H, 6. It's got a triple bond. It's butane, but you need to tell me where the ine is. It's after the 2. So that is a 2-butyne. Okay? Let's just do a random one now. I'm going to draw one, and let's see if we can name it. So I'm going to go 1, 2, 3, 4, 5, 6. All right? So we're going to need to know what the prefix for 6 is. We'll have to think about that, maybe go back to a page. And I'm going to put a triple bond right there. And then we'll fill in the H's. H3, H2, H2, that's full, H3. The formula, how many C's have I got in that thing? C6, and how many H's? 2, 4, 10. H10. All right. 4-hexyne. So you want to call it a hexyne. Hexyne. And you're saying it's 1, 2, 3, 4. What if we numbered it from the other end? What if I numbered it from this end? And remember, it's what it comes after. 1, 2. Which do you think would be better? Using a bigger number or a smaller number? Yeah, we want to keep the numbers small. So that's how we name it. If the triple bond looks like it's way at the other end, we simply start numbering from the other end. Okay? So we want to keep our numbers as small as they can be. So we don't want to have a big number. If it's at the back end of a molecule, we'll just start counting from the other end. That makes this 2-hexyne. Okay? Yep.
So like for 4, we would have to like count another way, or
That's for 4 we need the numbers because it could be 1 or 2. But if I had it over here, like if I had the triple bond over here, it's a 1. It's still a 1. We always will count to get us the lowest number. You always start counting from the side that it's closest to. Yeah. No, that's just to help us see how many and whereabouts it's located. Okay, 2 things. The general, that's supposed to be an L, formula for alkenes. CN H. And when we had alkenes, what did we have there? I don't have any alkenes on my page. It was on the previous pages. But what was true about the number of H's for all of our alkenes? What was that? Doubled. 2n. 2n. Notice for alkanes it was 2n plus 2. Now we're down to 2n. General formula for alkynes, CnH. This one's not as obvious. Again, we've got 2n. Yep. Minus 2. Minus 2. You need to take 2 more away to make the triple bond. All right? Looking okay? Let me jump down to an example or two. I do want you to write this down. Let's take a look. Let's write this down. To name isomers of alkenes and alkynes, because we did them both together. With 4 or more carbons, put a number in front of the name that represents the carbon at which the double bond starts. In other words, which carbon does the double bond come after? That's another way of thinking of it. The numbering starts from the end that gives us the double bond with the lowest possible number.
Just write the one bolded or all?
No, you're going to write all of them. You're going to write all of them, that whole thing.